So we made a small RDF graph that stores information about three things that have type fruit and have different colors, red and yellow. Now the next step is, once we have an RDF graph, how do we get information back out of it? Well, we use a query language called SPARQL, which is the language for RDF graphs. So let's see how this works. I've got my fruit store that contains my list of triples, and I'm going to pass that through a graph store command called SPARQL query, and then I build the query inside a pair of quotation marks using the SPARQL language. What this says is, it says select everything in the triple store that meets the following condition, and this thing here describes a triple. The first part says you're going to fill something in here. That could be anything, but we're going to give it the name fruit. This next thing, A, is shorthand for RDF type. So when we see that lowercase a in SPARQL, we know that it means RDF type. And the third part of the triple is something that is linked to example.org to specify that it's a fruit. So when we run this, it gives us the three examples of things in our triple store that have type RDF fruit: a banana, a cherry, and a strawberry. Now suppose we want to find out what the color of banana is. We construct another query, very similar. We say select everything that meets the condition described by this triple right here. In this triple, the first thing has to be a banana, because we're asking a question about bananas. The second thing is the predicate color, because we're asking for the color. And the third thing here is the variable that gets filled in with the color that a banana is. Let's try it. Banana is color yellow. Now suppose we wanted to find all red fruits. This is an example where we're going beyond something that is stored in a triple. Let me evaluate it. We can see that it works, and we'll talk about how it works. Okay, so it's pulled out cherry and strawberry. So what this query says is, it says select everything where, and now we have a pair of triples. So our results have to match both of these triples. It has to be a fruit that has type fruit, and this same variable is used. It has to be the same fruit that has color of red. So this thing, first we put cherry in here. Cherry is a fruit, cherry is red. We put banana in here. Banana is a fruit, but banana doesn't match this next triple because it doesn't have color red. And then we try strawberry, and that works. Now this starts to show you some of the power of SPARQL. We can create queries that are complicated enough that they're pulling information from all kinds of different places and testing it against testing the bits of it against one another to see whether or not they match particular constraints. And in this way, the system is able to make inferences about things that it hasn't specifically or explicitly been told. Now, if you're familiar with SPARQL, or you plan to learn SPARQL, then this is a nice syntax because you can just type raw SPARQL commands into it. If you want to work in Mathematica, there's something called symbolic SPARQL, where instead of writing SPARQL syntax, you build up SPARQL queries by putting the pieces together with Mathematica predicates. So here's an example. I'm saying a color pattern says an RDF triple that consists of a fruit, schema, org color, and a color. So that's a pattern, and basically it's describing a triple. Then we use the command SPARQL select to look for things of that pattern, and it gives us bananas are yellow, cherries are red, strawberries are red. It gives us three of the triples in our triple store. Remember that there are actually 6 of them in there. The other 3 say that a banana is a fruit, a cherry is a fruit, a strawberry is a fruit. Now we can build up a query to find the color of a banana. We're looking for a triple where the first item is banana, the second item is color, and the third thing is a SPARQL variable. And once again, we pass this into the SPARQL select command, and it tells us that bananas are yellow. And here's our example that we just did, where we find all red fruits. Okay, this triple store that we've been playing with, these six triples that describe fruits and three fruits and their colors, is very simple, and it's so simple that we would never use something like RDF or SPARQL to explore this small of an amount of stuff. If we want to be able to tap into enormous amounts of data, we can use SPARQL on queries against data sets that are online. So for example, Wikidata is a knowledge base that has more than 56 million items in it. They've mostly been extracted from Wikipedia. Anyone can edit them. And there is, on this web page, there's a nice collection of information about how you might get at this through a browser. We're going to get at it through code instead. So first of all, we have to specify where the data is. This is called an endpoint. So I'm saving this URL in the symbol endpoint. Now the next thing, which I'll explain in a minute, is a query in SPARQL which searches for a query in SPARQL which searches for the highest mountain in the world. So we save our query, and then we call a command called SPARQL execute, and we give it the endpoint and the query, and it goes out to the internet and it retrieves that information. Now this takes a while, so I evaluated this input here before I started the tutorial. It returns an association. The name is Mount Everest, and the elevation is 8,848 meters. Now we can check this against Mathematica's entities by asking for Mount Everest's elevation, and it gives us the same result. Now if we stop to think about this for a second, this is actually pretty remarkable. In the past, if you wanted to retrieve something like that, what's the highest mountain in the world, and you didn't know, maybe you want to know the third highest mountain in the world if you already know Mount Everest is the highest one. So you say, okay, you go to the library, you go to the reference section of the library, there's a book called Information Please Almanac, and it contains lists of things like the tallest mountains and the longest bridges and that kind of thing. We can get that information as people by going and looking in Wikipedia or somewhere else, maybe the online encyclopedia, but to be able to tell a machine, go out and find the tallest mountain in the world for me and return that information to me, is quite interesting. Here's another query. This time I'm going to ask for, and this query is quite similar to our previous ones, but what I did was I asked for 10 results instead of 1 result. And now what I have is I have a table of the 10 highest mountains in the world. And if you know the first two, probably most people do, probably most people, unless there's have some reason to know something like this, don't know many of the other ones. And it gives us the height for each one in meters. Now we can format this as a table. We could ask for names, for example, with typical table syntax. We can ask for elevations in the same way. We use a replace all command to get rid of the formatting. And if we combine this into a pure function, we can map it over the results, and then we have a nice little table of our 10 highest mountains. So how did we do this? Well, let's see how we specify a query in Wikidata. We use a SPARQL select statement where we say select a variable where it meets particular conditions, and those conditions are specified as triples. We say select distinct if we want to get rid of duplicates. We say order by something. In this case, we want it to ordered by elevation. And limit n is how many results we want. 1 if we're just looking for the highest one, 10 if we're looking for the top 10. The first triple in our query says mountain. This is the variable that we're matching. WDT and WD are Wikidata identifiers for items, that's WD, and for properties. We can actually use Wikidata to look these up. If we look up Q8502, that tells us that the item is a mountain. If we look up P31, that property, that tells us that it's an instance of a mountain. The other queries are slightly more complicated, but they use what are called property paths and describe a chain of triples that are going to be followed in order to get a result. And in the last triple tells us that we want results returned in English. Now there's a very good tutorial here on Wikidata if you want to learn how to construct SPARQL queries. And in the further examples section, I have a couple more examples of how you would actually do this in Mathematica.